Welcome to The Explainer. Today, we're diving into the Research Detectives Toolkit to figure out how scientists actually connect the dots between our habits and our health.
Okay, so let's just jump right in. You see these headlines all the time, right? Something like coffee drinking linked to pancreatic cancer. But how do scientists even start to figure that out? It's not like they can lock people in a lab for 30 years. Instead, they have to observe the real world. But how they choose to observe, well, that changes everything.
And this is where it gets really interesting. Epidemiologists basically put on their detective hats. They've got a whole set of specialized tools, these different study designs, and the real skill is knowing which one to use to crack a particular case. So let's look at two of the most important ones.
All right, let's grab our first tool and see how it works. This is often the first one a researcher pulls out of the bag. You can think of it like their magnifying glass, perfect for a quick look at the scene. The best way to get this is with that snapshot analogy. A cross-sectional study is exactly that. It's a picture taken at one single moment in time. Researchers go into a population and at the very same time, they measure two things: who's been exposed to something and who has a particular disease. And this is basically how they organize that photo they just took. The data gets sorted into this simple little grid. You've got people who were exposed and have the disease, people who were exposed but don't, and so on. Since everything's captured at once, it gives them a really clear picture of what's happening right now. And what this all boils down to is that this kind of study answers one key question: what's going on right this second? It measures something called prevalence, which is just the proportion of existing cases in a group of people, so it's great for understanding the current burden of a disease. So what's the catch? Well, these studies are fantastic for generating clues or new ideas. We call them hypotheses because they're pretty fast and they don't cost a ton of money. But, and this is a huge but, they have one massive critical weakness, a real blind spot for any detective. Yeah, this quote from our source material, Gordis Epidemiology, just hits the nail on the head. Because you measure everything all at once, there's no way to know which came first. Did drinking coffee lead to the disease? Or maybe, did getting the disease somehow change people's habits and lead them to drink more coffee? The snapshot can't tell you. It's that classic chicken or the egg problem.
So, to solve that exact problem, our research detectives need a totally different tool. If a single photograph isn't enough to solve the mystery, well, then they need to watch the whole movie. And that brings us to the cohort study. Instead of one single picture, this study follows a story as it unfolds over a long time. Researchers identify a group of people, a cohort, and they follow them for years, sometimes even for decades, just watching to see who gets sick and who stays healthy. And the process is actually pretty straightforward. A researcher starts with a bunch of people who are all healthy. They find one group that's been exposed to what they're studying, let's say smokers, and another group that hasn't. Then they just hit the play button and watch what happens to both groups over time. Now, because they're watching over time, they can measure something way more powerful than prevalence. They measure incidence, and that's the rate of new cases showing up. This lets them calculate the actual risk. What's the probability that a smoker will develop heart disease compared to a non-smoker over the next 10 years? A cohort study can actually answer that. So, this is how the movie study solves that chicken and egg problem. You know the exposure came first because you made sure everyone was healthy at the start. This gives you much stronger evidence for a cause and effect link. But as you can probably guess, following thousands of people for decades, like they did in the famous Framingham Heart Study, well, that's incredibly time-consuming and super expensive. So let's put these two tools right next to each other. When would our research detective choose the quick snapshot over the epic, big-budget movie? This really boils it all down. A snapshot tells you what's happening now and finds a potential link, an association. A movie, on the other hand, tells you about future risks and gives you powerful evidence that one thing might actually cause another. They're asking totally different questions. Okay, so why does any of this actually matter to you when you're just scrolling through the news? Why should you care about the difference between a research snapshot and a movie? Because it tells you how seriously you should take that headline. Understanding the tool the researchers used lets you become a more critical, more informed consumer of science. You can actually weigh the evidence for yourself. So let's bring it all home. The next time you see a study linking, blueberries to better memory, you can ask the right question. Was it a snapshot study, an interesting association that needs more digging? Or was it a long-term movie study, which gives much stronger evidence of a real benefit? One's a clue, the other is way more convincing.
And that's your new detective tool, just by asking that one simple question. Did the researchers take a quick photo, or did they watch the entire film? You can better understand the world of health science and make smarter decisions for yourself.